This video is the practice problem number 3 from the Vesper worksheet number 1, and it is the problem NH3. The first thing I have to do in figuring out this worksheet is to count up my valence electrons. So to count my valence electrons, I need a periodic table of the elements. So I'm going to look up N, and I'm going to look up its valence electrons. So here's N, and its valence electrons are right here above there. They are 5. And then I'm going to look up H. Their valence electrons are right here, and it is 1. So when I go back to the previous slide and I'm counting up valence electrons, remember that was 5. And each one of these are 1, and there are 3 of them. So I'm going to say times 3. So the total of valence electrons is 8. When I go to create my diagram, the first thing I'm going to do is going to put my loner in the center. That's N, goes in the center. And I am going to connect the H's to my central atom. The next thing I'm going to talk about is kind of a side note, and it has to do with hydrogen. So before I start distributing electrons, which would be my normal next step, I'm going to show you a diagram of a hydrogen Bohr model. So it's got 1 proton in the center, and it's got 1 electron on its one and only ring, which happens to be the K. Now, if you go back in time, you'll remember that the K orbital only holds 2 electrons. It can't hold any more than 2. So when I start distributing electrons here, this, remember, is already 2 electrons. The stick is worth 2 electrons. So I already have 2 electrons on that hydrogen. I have 2 on this one, and I have 2 on that one. So I've already used up 6 electrons, but they can't go on any of the hydrogens. So the rule is, if you have extra electrons, they go on the central atom. So N is my central atom, and that's where the last 2 extra electrons will go. I could have put them here, or I could have put them there. Any of these 3 locations would have been perfectly fine. You just keep them together, and you put them on the central atom so where they're going to be, noticeable in one of those 3 locations. So this is what my diagram looks like, and I can construct my AXE and then go look up what its shape is. So the A is 1. Remember, the A is how many central atoms do I have? And the answer to that always is you have 1. So A is always 1. The X is how many things do you have connected to the central atom, and in this case it's 3. Hydrogen, 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 3. And the E is how many extra electron pairs do you have on the central atom, and it's pairs. So how many pairs are in 2? The answer is just 1 pair. So my XE, my A is 1, my X is 3, and my E is a 1. So I'm going to go look up the shape on my AXE of a 1, 3, 1. You'll notice down here, they don't even say the A in the chart because it's always 1. The X was 3, and the E was 1. That means when I go to write down the shape, it will be trigonal pyramidal. So that's the shape. For my shape, it is trigonal pyramidal. Okay, and that is the practice problem number 3 off of the Vesper worksheet.